Now that we've had our whirlwind tour of the periodic table, let's look at different types of bonds that atoms can make. So the first type that we're going to talk about is called an ionic bond. And ionic bonded atoms can form something called a compound. And a compound is a substance that is made up of two or more types of atoms. So we'll start with two atoms, sodium and chlorine. And we'll look at sodium. We'll see that it's in our first group in the third period. So sodium has 11 protons. It has 11 electrons. And the first 2 electrons are in that first shell. The next 8 electrons will be in the second shell. And then we have that 11th electron that's hanging out in that third electron shell. That's why it's the first element in the third period, because we're starting to fill that third electron shell. Now when we go across the period over to group 7 here, we find chlorine. Chlorine has 17 protons and therefore 17 electrons, and we fill the shells in order. So we have the first 2 electrons filling the first shell, then we have the next 8 electrons filling the second shell, and then we have 7 electrons occupying the third shell. So what we can see straight away is that we have an extra space in here that needs to be filled. Over here we have 7 spaces that would need to be filled in order to complete these electron shells. Now, as we know, atoms like to have complete electron shells. So for sodium to do that, it could do one of two things. It could find 7 other electrons somewhere, or it could find a way to get rid of one of them and revert down to the next lowest shell. By the same token, chlorine over here would do well to find another electron. And so what happens is sodium, when sodium and chlorine are in proximity, sodium can give up an electron and give it to chlorine. So now one electron that was in the third shell of sodium can now come over to chlorine and fill that one space in the third shell of chlorine, and at the same time get rid of the third shell of sodium. So now we have a completely filled second shell. So what we get when we do that are 2 charged particles, and we will call these ions. So an ion is any atom that's gained or lost electrons. So when an atom gains or loses an electron, it gives up its atom status and becomes an ion. So now we have sodium ion, which is positively charged by virtue of the fact that it has 1 more proton than it does electrons. Since it's given 1 of its 11 electrons away, it now has 10, and it has a positively charged proton now that is not balanced by the electron. Over here we have chlorine, which has now gained an electron. So we have 18 negative charges to the 17 positive charges in the nucleus. So we now have a negatively charged ion over here. So we have positively charged sodium, and we have negatively charged chlorine. And so ions come in 2 types. Cations, which are our positively charged ions. So this would be sodium ion. And we can think of cation being an easy thing to remember for positive because it has a T in the middle of it that looks like the plus symbol in representing a positive charge. An anion, on the other hand, which is what we get when we get chloride ion, an anion is a negatively charged ion. And you can remember negative by the N in anion. So anion, N like negative. So anions are negatively charged ions, and cations are positively charged ions. And when you have this kind of giving an electron from one atom to another to make 2 ions, then we have oppositely charged things. And opposites attract. So sodium and chloride will get together and form an ionic bond, which creates a compound that we know as table salt. So this is the stuff we sprinkle over our food. Now what's interesting about this is that this is not a very strong bond. And we all know what happens to salt when we put it in water. It dissolves and it dissociates. So the crystals that are formed when we create an ionic compound, like sodium chloride, the crystals that are formed when it's a solid will dissolve and what we call ionize when we put them in water. So that now we'll have sodium ions floating around in water and chloride ions floating around in water, and the compound has dissociated into its component ions. So it's not a very strong bond, it's fairly easily broken. The next type of bond we'll look at is a covalent bond.